Logarithms. This is something totally brand new. You've never ever heard of it, seen it, or done anything with it. But to introduce it, let's talk about inverses. What is the inverse of addition?
Subtraction.
Write it down. Subtraction. And here is where the inverse is handy. These guys in the left-hand column are called expressions.
Yeah.
So look at this expression. 2 plus 4. Expressions are easy. All you do is simplify them. You're trying to find an answer. 2 plus 4 is 6. If you simplify it, you end up with 6. These guys in the right-hand column are called what? Equations. Okay, an equation, they just take part of the expression and they pull it out. So they're asking you 2 plus what is going to give you 6 for an answer.
4.
How do you solve it though?
6 subtract 2.
You undo addition.
You use the inverse.
You use the inverse. So instead of adding 2, you're going to subtract 2, subtract 2. X is 4. You're using the inverse. What's the inverse of multiplication? Division. And you need to use it to solve an equation that is using multiplication. 2 times what is 16? How do you solve for that? Divide by 2. Divide by 2. What's 16 divided by 2? X is 8. What is the inverse of a square root? So how do you tackle this guy? Square root of x equals 4. You square both sides. A square and a square root, they just cancel each other out. So you just have x equals 16. Taylor, what is the inverse of exponentiation?
Squaring. Oh. Exponential.
If you're going to guess, what are you going to guess? What's the square root of exponentiation? Logarithm. Logarithm. You did call. Good job. Thomas. Thomas Wilkin. Nailed it. Okay, now, a logarithm is just an operation. It's like addition or subtraction or multiplication or division or square rooting. You alright with that? Logarithm. What is the answer? 2 to the what power is 16?
How come they haven't introduced this till now? 4.
The answer is
Probably complicated.
4. So Taylor, you just type 2 on your calculator,
Yeah.
and you'd go 2 times 2, enter, times 2, enter, times 2, enter, until it's going to give you 16. So now, Katie, your variable is going to be in the exponent position. So it's a little bit challenging. It's pretty tough. Solve these. 3 to the what power is 81? So you get on your calculator. Grab your calculator. Go 3 times 3 times 3. How many times? You just kind of guess. So you start, this is your base. You're going to go 3 times 3. That's 9 times 3 is 27. Sweet. If you do it 4 times, you're going to end up with the answer of 81. So the question is this: 3 times itself, how many times is going to give you 81? Then your answer is x is 4. Try 4 to the what power is 256. So they're asking you this: 4 times itself, how many times is going to give you 256? How'd you get 4? What about 5 to the x power equals 125? 5 cubed is 125. So x is 3. What about the bottom one? 2 to the what power is 32? 2 to the what? X is 5.
Is that what we're doing today?
Yep. But let me show you how to write this in English using a logarithm. Using a logarithm. Here we go. Problem number 1. The logarithm.
Is there a symbol for that?
Yeah. The symbol for logarithm is Log.
Yeah. That's on the calculator.
It is.
Yeah.
So the logarithm,
Use it.
not yet. The logarithm of 81 in base 3 is what? Is 4.
So how do you write that in your calculator?
You don't. Not yet. No calculators yet. So the logarithm of 81 in base 3 is 4. Okay, try the rest. You guys go the rest to English. Let me pause it. The base. What does the base mean?
It's the number that's gonna be exponent to
Perfect. Look at this guy right here. This whole thing, if you have 2 to the 5th, that whole thing is called the power. Thomas, what's the 2 of the power? 2 is called the what? 2 is the base. What's the 5? What's the name of the 5 position? Exponent. So, the base is going to be easy. The base is just referring to the base of the power. Alright? Let's try this guy right here.
erase that completely. Yeah, I tried, bro. Yeah, no. You're so funny. I got it.
Alright, let's try this one. Now,
Yeah.
okay, look at this. Thomas. 4 to the x equals 4 to the 8th.
That's false. Wait,
What's the answer? Why is the answer 8?
because it's like equals the other.
It cannot, why can it not equal anything but 8? A equals A. So Emily, does that make sense? Look at this. 4 to the 8th has to equal 4 to the 8th. That's like this. That's like Thomas said A equals A. 7 has to equal, the only thing 7 can equal is 7. 7 could equal like 5 plus 2. It's got to simplify and give you a 7. So this has to simplify and give you 4 to the 8th. So Danny, here's the key thing. If your bases are the same, that's going to be super easy. If your bases are the same, then your exponents are going to be the same. Every time. Every time. Stokes, that makes sense? So look at this guy right here. What's wrong with this one? 25 to the 3m equals 625 to the negative 2m. Okay, what else? What else is wrong with it?
The variables are size.
What else is wrong? Look at these guys right here. Okay, the base is not the same. So you cannot do anything until the base is the same. So Katie, can I manipulate them so the base is the same? One of them or both of them? Find the common base. What is the common base? 25? So can you rewrite 625 as a power with the base of 25? If the base is 25, what would the exponent be? Well, I need this to equal 625. 2 is 25 squared the same thing as 625? Is it? How could you find it? The hint is this. Usually, Katie, you can change it into the smaller one a lot of times. So on your calculator, type in 25 and you just go 25 times 25 until it equals 625. So here we go. I'm going to manipulate this and I'm going to write it as 25 squared raised to the negative 2m power. On the left, I did not have to change a single thing. 25 to the 3m. Now Danny, your bases are exactly the same. So what does that mean? If your bases are the same, what does that mean? Then your exponents have to be the same. Okay, look at this right hand side. What do you do when you raise an exponent to another power? What do you do with the exponents? Add, subtract, times, or divide? Times. Good. If you've got this, if you got x squared times x cubed, that's x2 plus 3. If you got x squared raised to the third, that's x2 times 3. So let's times these two guys together. So you got 25 to the 3m equals 25 to the negative 4m. Now, all you do is this. If your bases are the same, then you just set your exponents equal to each other. 3m equals negative 4m. Now what? They're equal. So now you get, it's just an equation. This is now becomes a 6th grade problem. Solve it. How do you solve that equation? Add 4m. Add 4m. So you have 7m equals 0. Divide by 7. Divide by 7. What's 0 divided by 7? 0. 7 times what number is 0? M must equal 0.
I don't know, but I'm pretty sure.
There's a solution. M is 0. All you do is manipulate it so the bases are the same. This is the art of manipulation. This is what math teaches you. Good manipulator. Look at this guy right here. Let's call this problem number 3. Alicia. Are the bases the same? 64 to the 2m plus 2 equals 4 squared. What's the base of this expression on the left? What part's the base? 64. What's the base on this guy on the right? Okay, you're in trouble because they are not equal. Can you rewrite them so they are the same?
Yeah.
And the question is this. Look at this. This base is a 4. So you want to know, can I make this be rewritten as a base of 4? And the question is this. 4 to the what power is the same thing as 64? So get on your calculator. Do 4
16.
times 4
3.
times 4. How many times do you have to do that till it equals 64?
4 to the
3?
yeah.
So you have manipulated. You have rewritten 64 as 4 cubed.
So
Now it's going to be 4 cubed, and then to this power of 2n plus 2. On the right, we didn't have to change anything, so it's going to be 4 squared. Now what? Tyson, what's next?
Add the exponents and stuff. You
Times them. So if you times the exponents, you've got to do the distributive property. You got to multiply both those by 3. So you end up with 4 to the 6n plus 6 equals 4 squared. Now, Emily, your bases are equal. So what does that mean? That you can set their exponents equal. So let's do that. 6m plus 6 equals 2. Minus what? Minus 6 minus 6. So you've got 6n equals negative 4. Now what? Divide by 6. Divide by 6. What's n equal to? Negative 2/3. What kind of a number is negative 2/3? Is it a whole number, an integer, a rational, or irrational? It's a rational. Rational numbers are fractions. Okay, you guys try this one on your own.
Get rid of your 6 and just write 2n.
Yeah, as soon as you rewrite this as 6 cubed, now your bases are the same. So if your bases are the same, your exponents have to be the same. So negative 2m minus 2 has to equal 3. Plus 2, plus 2, negative 2n equals 5. Divide by negative 2, divide by negative 2. N equals negative 5 divided by 2.
Okay, I know what I did wrong, man.
Here we go. Number 1, Tyson, give me the English sentence right here using logarithm. Give me the English sentence. What is this saying?
It says
The logarithm of 361 in base 19 is 2. Alright, here's the mathematical shorthand. So your instructions are to rewrite each equation into logarithmic form. Here's the shorthand. Log base 19, that's a subscript. Remember what a subscript is? Remember this for slope? Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Those are subscripts. That's what this is also. So log of base 19, let me erase that. So you've got the logarithm of 361, that goes right there. So the log of 361 in base 19 equals 2. Alright. Katie, give me this one. 81 to the 1/2 equals 9. How do you write it? With mathematical shorthand. Log of, well, the log of 9. Where does the 81 go? The little subscript. So the log of 9 with the base of 81 is 1/2. Porter, can you go backwards?
Yeah.
Let's see it.
Backwards.
Can you take a logarithmic form and rewrite it in exponential form?
So just write it like that.
This is Taylor Porter coming at you live from AP. Everybody give it up for Taylor Porter. Nailed it.
That's right.
Way to be, Porter. What about this guy right here? Emily, let's see it. If you want to come write it, come write it. Emily Beddoes.
Don't say my name, sir.
No pressure, Emily.
Say my name, sir.
Let's get to video.
I'm just gonna beat you up.
I want to do one.
19 to the second power equals 361. Nailed it. Yes.
I want to do one.
Excellent. Next slide. Okay, evaluate each expression. So the log of base 3 of 1/27 is what? If you rewrite this in exponential form, what does it look like if you write it in exponential form? I need a base, an exponent, and it equals something. 3? What's the exponent? X is 1/20. Okay, the logarithm is this. That's the x. That's what you're trying to find the log. The log of 1/27. 1/27. What is the log of 1/27 when the base is 3? You think x equals -3? Did you do that? Why is it a -3, Thomas? What is 3 cubed? 27. But I need my answer to be a fraction. 1/27. What is 3 to the -3rd power? What do you do if you come across a negative exponent?
Put it over 1.
What do?
You have to make it positive. There you go.
1/3 cubed. One more 3 on bottom. 3 times 3 times 3. Sweet. So if you ever come across a negative exponent, right now if you look at it as a fraction, it's on top of the fraction. All you do is move it to the bottom. Or if it's on the bottom, move it to the top. Okay, try this one.
I have a question.
Do this. You just rewrite it as the base is 4, exponent, that's what you're looking for, equals 16.
So you pretty much just figure it out.
You start with 4 on your calculator and you go 4 times 4 until it equals 16. Then you count how many times you did that. So your answer is 2. Okay, this one right here. This is something sweet. There's going to be some sweet phenomena that happens right here. So everybody take a breath. Watch it on this guy right here. Okay, Danny. I need a base, an exponent, and what it equals. Okay, look at this guy. The log of base 14 or base 4 of 16 is 2. So the 4 goes here. The 16, that's what it equals. And the 2 is the exponent. Okay? What is my base going to be? The base is going to be 18. What does it equal? It equals a plus 3. Now, what is the exponent? What's the exponent? What was the exponent on this one? It was 2. It's what it equaled. So whatever it equals, that's the exponent. What does this equal? What does this equal? It equals log base 18 of 3 minus 2a. Does that make sense?
So it's like equal to it?
Yeah, the base is 18. 18 to this power right here. This is the exponent, what it's equal to. That is your exponent. That is your base. And this is what it equals.
Do you write on there though, the exponent 18, exponent x equals 3 minus 2a? You write it out.
Oh. Okay, Dallas, say that again. That's pretty sweet.
Alright. You write, okay,
18
18, exponent of x
exponent of x
equals 3 minus 2a.
of 3 minus 2a. Can you rewrite it like this? You can. But check this out. Dallas, what is, if you have x squared, so I've got, and I take the inverse operation, which is a square root, what happens? They cancel out. And it's just x. Or if you have this, what if you have the square root of x and you take the inverse operation and you square it? What happens? This is the cool phenomenon that's going on. Your answer is just x. You have right here, you have an exponent, but you have a logarithm. An exponent and a logarithm are inverse operations. So if you have 18 raised to the log of base 18, that is exactly like a square root of something squared. This whole mess is going to cancel. It's an inverse operation. It undoes itself. So you are left with this. On the left side you've got 3 minus 2a. On the right side you have a plus 3. So anytime your base is the same thing as the base of the log that you raise it to, they cancel out. So look at this one on the right. Look at log base 20 equals log base 20. What's going to happen to those log base 20? They are going to cancel each other out. They're inverse operations. So on this one, you're just going to have a negative 5b minus 2 equals negative 4b. And then you just solve for the variable. Solve for a. This a is 0 plus a 3a plus 3 equals 3. You're right. Minus 3 minus 3. 3a equals 0. A equals 0. No. Look at this one. Try this one. The 5b, the negative 5b minus 2 equals negative 4b. What does your instinct say to do first? You need to solve for b. What do you want to do very first? Let's subtract 9 from both sides. Minus 9 minus 9. So you're going to have 9b, 9 to the b plus 4 power equals, what's 22 minus 9? 13. Now what does your instinct want to do? Can you get the same base? This base is a 9. This base is a 13. No. If you can't get the same base, you're going to rewrite this in logarithmic form. Rewrite this in logarithmic form. So what is it going to be? Log of base 9 log, the log of 13 in base 9 equals b plus 4. Then what? You gotta solve for b. You're almost done.
So you subtract.
So all you do is subtract 4. Subtract 4. But these guys are not like terms, so you can't add them. So it's just log base 9 of 13 subtract 4 equals b. That's your answer. That's as far as you can go.
This is good.
It's gonna be a horrible assignment. I'm gonna cry. Sure, like
Let's try the other one. What about this guy? What do you want to do very first?
-1 almost.
Minus 1. So you got 10 to the x minus 8 equals 11. Are your bases, can you rewrite them so they're the same base? So you have to go to logarithmic form. Log base 10 of 11 equals x minus 8. Add 8. Add 8. So your answer is log and base 10 of 11. Oh, plus 8 equals x.